Each load in a series circuit dissipates electrical power as energy is converted from electrical form into another form such as heat or light. The amount of power dissipated by each component depends on the voltage drop across that component and the current flowing through the circuit. Because the current is the same everywhere in a series circuit, differences in power dissipation are primarily influenced by the resistance value and resulting voltage drop of each load. Power in a circuit can be calculated in several ways. It can be determined using voltage multiplied by current, using current squared multiplied by resistance, or using voltage squared divided by resistance. All three relationships are valid, and the correct choice depends on which values are known. In a series circuit, once the circuit current is known, calculating power for each resistor becomes straightforward. The total power supplied by the source must equal the total power dissipated in all loads combined. In other words, if you add the individual power values of each component, the sum will equal the total circuit power. This reflects the principle of conservation of energy. Energy supplied by the source must be accounted for within the circuit. It is critical that components are selected with power ratings that exceed the calculated power dissipation. If a resistor is required to dissipate more power than its rated value, it will overheat, degrade, and potentially fail. In practical applications, engineers and electricians include a safety margin to ensure reliable operation and to prevent thermal damage over time.